So it's equal to 128 over 3. Okay. So by tabulating it this way, it's so much easy to calculate your second moment of area. Then finally, we can find your Iyy, which is equal to Iyy of 1 plus by Iyy of 2. So it's equal to 64 over 3 plus by 128 over 3. Okay, so 64 over 3 plus by 128 over 3 is equal to 64. Okay, so I would strongly recommend that you get used to this technique. As I said, it helped me a lot. Okay, you don't make so much mistake. Okay, so we have determined Iyy. Next, we want to find our Izz. Okay, so I'm going to copy the same diagram. Okay, so now ZZ is the axis of interest now. And we can immediately draw the centroid along ZZ. We don't need to calculate. Let me tell you why. Okay, I'm very sure that this is the centroid position of the centroid, and due to what? Observation. So what do I mean by due to observation? Right? So we know that the area above the centroid is the same as area below the centroid. So this is purely observation. Okay, I don't want you to waste your time to do these steps again. Okay, to find the centroid, it's going to be exactly as I've drawn down there. Okay, so now we are going to divide this into 2. Okay, and this is our 1, and this is our 2. Okay, so section 1 and section 2 again. So the axis of interest is our ZZ axis, as you can see now. So we know that over here, anything parallel is the width. Anything that is perpendicular, this will be the what? The depth. Okay. So I'm going to do together. Okay. So IZZ is equal to IZZ1 plus by IZZ2. Okay. So IZZ1, the width is 2. The width is 2. The depth is 8 cube over 12. And then this is plus by IZZ2. The width is 4. The depth is 2 cube divided by 12. Okay. So this is equal to 2 times 8 power 3 divided by 12 plus by 4 times by 2 power 3 divided by 12. This is equal to 88. Okay. So 88 inches to power 4. Okay. So as you recall, we know that I is equal to width d cubed over 12 plus by the area, right? Big Y bar minus small y bar squared. Now you realize that we did not use this term at all. This is because, okay, big Y bar is equal to small y bar. So this term over here is equal to 0. Okay, because the centroid at section 1 is on the z-axis. The centroid in section 2 is also on the z-axis. Okay, and the global centroid is also on the z-axis. So don't waste time to include this because it's going to be equal to what? It's equal to 0. Okay. So now we have all the information ready. We know our IYY, and we also know our IZZ. Okay. So the next thing is just to find our stress distribution. Okay. So to do that, I'm going to take this diagram. Now, this diagram is really important now. Okay. Because this diagram is going to tell us tensile or compression. Okay. So I want you to get used to doing this. Okay. When you come to calculate the area, now I want you to find that to tell yourself that this is the y direction, okay, and the horizontal is the z direction. Okay, the horizontal is the z direction. Okay. Right. So I'm also going to, this diagram is going to look messy, but it's okay. I'm also going to superimpose our position of centroid. Okay. So this is our position of one of our centroid about along the z-axis, and the next one is our centroid about the y-axis. Okay, so those two are our centroid. So we want to find the stress at point A. Okay, and there's two formula that we're going to use, or it's a combined formula. So we know it's my. Okay, so let me use a different color over here. So we know that it's my over Iyy z, and then we also need the formula to find mz over Izzzy. Okay, and now, okay, so let's focus on point A. So point A is this point over here, right? So my is going to induce a compression at point A, right? So we know that this is minus. Okay, and then mz is also going to induce a compression at point A. So both are what? Minus. Okay, that's why I've been telling you, don't worry about positive and negative. By looking at the moment vectors, you will know. Okay, so we know now we're going to plug in the formula. This is the easy part. So now mz, so it's minus mz. I forget what is our mz. Mz is equal to 9397. Okay, so my. So we're going to do my first, 3420. Okay, so 3420 divide by Iyy now. So Iyy we calculate to be 64. Okay. Now the next part student will make mistake, or even engineer will make mistake, is the z. Okay, that is why I label this as z and I label this as y. Okay, so z from the centroid, the y-axis centroid, the distance is equal to 4. Okay, so how this remind me is z is on the horizontal axis relative from the centroid. Right, so let me be more specific. This is our z for point A. Right, then we minus by mz. Forgot what's mz. 9397. 9397. Right, the y is equal to 1. the IZZ is equal to 88. Okay, so this distance from here to here, right? So this is Y for point A. Okay, so finally, this will be equal to 3420 times 4 divided by 64. 3420 times 4 divided by 64 is equal to 213 minus 213.75, and then minus again 9397 divided by 88. 106.784. So our stress is equal to 213.75, 106.784. You add them together is 320.534 minus by 320.534 psi. Okay. Then the next point we want to find is stress X at point B. Okay, stress X at point B. So now B is at this location over here. Okay, so if we were to look at point B, all right, and at point B, the moment induced, the moment at Y will still be compression, so minus my over Iyy multiplied by Z. But the moment, so at point B, the moment due to Z is positive. So mz over Izz multiplied by Y, right? So the only thing that changed over here, so if I were to write down the moment again, so it's minus 3420, right? Multiplied by 4, divide by 64. Now this will become what? Plus 9397 multiplied by 1, divide by 88, right? So this will be equal to minus 213.75 plus by 106.784. So this will be equal to, I'm just going to write below. So this will be equal to 213.75, 106.784 is minus 106. So 213.75, 106.784 is 106.966 minus 106.966 psi. Okay. So lastly, we want to find stress X at point D. Okay. So you look at point D, right? The first one is my over Iyy. Oh, we don't know yet. Okay, we just put my over Iyy. Then we have mz over Izz. Okay. And if we look at point D, right, this is where point D is on, right? At point D, right, the Z distance over here is equal to 0 because it's exactly at the what? Centroid, right? So where's at point, sorry, I got this wrong. Hey, Eugene, wake up. Is the Y, hold on. See, now I'm ready. The Z. No, I'm correct. I'm correct. The Z over here, right? The Z over here, this is equal to 0, right? Because it's a horizontal movement, right? So Z and the centroid along the y-axis are in a line, so it's equal to 0. Okay. So now if we look at the moment about Y, right? Moment, hey, sorry. the z is equal to 0, right? The y, right? The y is not equal to 0. The y over here is equal to 8 divided by 4.